Now, away from the first principle, the approach we use in differentiating functions from first principle to rules. Now, one thing about calculus in the minds of students is that calculus is just about rules. But I have tried to make it, clear that calculus is not about rules. It's far bigger than rules. Now, these rules just help us to cut the process so that it saves us a whole lot of time. But then if you just approach calculus as set of rules, you will miss the whole point about what calculus is. But we are going to learn the rules. We want to save ourselves time. We don't want to go through, the ordeal of solving every problem using first principle. In fact, it would be so cumbersome, so unbelievable. So we are going to apply these rules. We'll talk about different rules in subsequent videos, but in this video we want to talk about the power rule. Now, this is one of the rules we apply when we are differentiating polynomials. All right, so we are going to use it to differentiate this polynomial here, x squared s cubed plus 3x squared plus x plus 3. So we are going to use the power rule to differentiate this. If you are differentiating this with the first principle, you know how cumbersome it will be, but you'll see how the power rule makes it so easy. Now, what is the power rule? This is the formula for the power rule. If y is equal to ax raised to power n, then dy dx will be equal to a multiplied by n x raised to power n minus 1. So this power will multiply the coefficient of x, and then you reduce the power by 1. This is the formula. So what we'll do here is that we'll apply this for all of this, each of the terms, and then string them together. Okay, so this process of stringing them together is the sum and the difference rule. If this is a plus, then it will be sum. If this is a minus, then it will be difference, right? Not minding what is here. This is actually an algebraic function or an algebraic term here. But if it were a trigonometric term like that, you still apply the sum and difference rule. When you differentiate this one and then there's a plus in between the next one, you have to add them up, right? So that is the sum and the difference rule. But to avoid the risk of making what is so simple complex, I'll just stick to the power rule and all that. So we are going to differentiate this. This will be dy dx. I'm differentiating this one now. So I'll take the power down. That will be 3x. Then I'll reduce the power by 1. So it will be 3x squared. Plus this squared will come down and multiply the coefficients. That will be 6, right? 6x raised to power, I'll reduce this by 1. That will be 6x raised to power 1, which is 6x. Then plus the power here is 1. There's a 1 here. So 1 times x is x. Then raised to power, I'll reduce this 1 by 1. That will be 0. So x raised to power 0. And then this one, for any constant term, you can assume there's an x raised to power 0 attached to it. X raised to power 0 is 1, so 3x raised to power 0, so that we can still apply these rules here. So 0 times 3 will be 0, so this whole thing will become 0, right? So this will be plus 0. Now, you don't have to do this for every constant term. This is a constant. 3 is a constant, 5 is a constant, minus 10, 20, like that. Any term where the variable of integration is not attached to it is a constant term. So this one like this is a constant term, and for every constant term you will see that when you differentiate using the power rule, you will get 0. Okay, so this 0 will multiply whatever is here, and what you'll be getting after will be 0. So anytime you see a constant, the derivative for a constant is 0. Okay, so this will be equal to 3x squared plus 6x plus 1 plus 1. So this will be the final answer. And if you have negative, if you have subtraction sign in between, then you just subtract, right? Now, what if you have a negative power? What if you have a negative power? For instance, I have, say y is equal to x raised to the power minus 3 plus 2x raised to the power minus 2. What would be the y, the x? Now, this also would apply the power rule. We apply the power rule. So we'll multiply the power by whatever is here. In this case, it's just 1, so it will be minus 3x. Then we'll reduce the power by 1, which is minus 4. Then plus the power, we'll multiply it by what the coefficient here. That will be minus 2 times 2 is minus 4. X raised to the power, we'll reduce this by 1. That will be minus 3. So this will be minus 3x raised to the power minus 4. Then minus 4x raised to the power minus 3. Okay? Now, how about fractional powers? How about fractional powers? For instance, if I have y is equal to x raised to the power 3 over 2, will the power rule still apply? Yes, the power rule will still apply here. So I'll take this power down. This will be 3 over 2x. Then I'll reduce this power by 1, which is 3 over 2 minus 1. Now 3 over 2 minus 1, this 1 over 1, will be equal to, the LCM is 2. The LCM is 2, so this will be 3 minus, this is 2 minus 2, so it will be 1 over 2. So this is equals to 3 over 2 x raised to power 1 over 2. So you can see that the power rule applies for positive powers, for negative powers, for fractional powers, right? So we look at other rules of differentiation in subsequent videos. If you enjoyed this video, don't forget to like and subscribe to International Classroom on our different pages and channels so that we get more audience, and also please share this video to someone who needs it. Thank you.